recording. Okay, so so in the last lecture we've been working on our data panel application, and we achieved a few things. So let's quickly run it again to see how far it is, so we can plot things. We now have also a listing of individual channels. Stop, remove. We don't have a remove function implemented. That was a homework, so then we need to restart it if we want to get rid of something, but that's fine. You can just add it again. Okay, and what still missing, as it seems, is the handling of the parameters we started to add. So I think that will need to be continued today. So let's see. Where was the parameters? Somewhere here-ish. Nope. Plugin H, plugin CPP. Right. So in the last lecture, we have just added this list here to contain the parameters temporarily, since we didn't have time to implement them on the actual plugins. So we will remove this hack now and implement it correctly. So the idea is here that we obtain a list of the parameters, how many they are, rather count from the parameters passed to, and then we will be setting them one after the other here on our plugin. So we need to create first individual values for them. So we said that we are going to work with our custom variant implementation. So what we want here is will be to create a function, ideally, that will return us a copy of well, an instance of a my variant, depending on the qvariant type that we feed to it. The reason to do it in an own function instead of doing it directly in the loop is that if we add additional features, additional functions on our plugins, which will take such my variant objects, we would like to be able to share the same conversion function for convenient and easy type conversion. Let's quickly check our my variant implementation, if the way it works is reasonable for copying. But as it looks, the assignment operator would be quite trivial. It just copies those three variables. So while we could of course try to improve it by adding some internal caching or a copy or write mechanism, etc., I think for our initial use case this will be good enough. So we of course need to determine where we want this conversion functions to live on, and a good place in fact will be here our already existing CDLL plugin. So we will make however those functions as static functions, so that they are not related to any particular plugin, that they are just more or less globally usable. So one would be qvar to myvar, qvar to myvar, or we could write it also like this: qvar to myvar, which takes a const qvariant reference var, and then of course we will want to have the opposite, myvar to qvar, which will basically do the opposite and give us, let's call it qvar here, myvar, and static. A static function on a class, just to be remembered, is a function which cannot access any members on a class because it exists independently of any instance of that particular object. And let's put them here. here we don't need to specify, oops, we don't need to specify static anymore. Zack. Oops, I thought I copied this. Let's try it again. So, right, so here, this one, we'll just use our malva to cuva to get from parameters at index I the value. Let's see here, asset parameters. Then we had implement this malva param const data that from params. This is this one data that should be correct, but it's not. Let's see. Okay. Will it prefer this one? Yeah, it prefers this. Oops. Prefers this one. I think one too much. And also count. Let's go with size. Count is like the Qt version of it. So if this works like this, we don't even need the second one. Okay. Zack. This semicolon is missing. Also, this thing here returns a okay or not okay. So we will use this value. So this is nice to have. And then, of course, here the other way around, we first need to resize our params. Resize. Where did we had this information saved? Plugin. Plugin has only a pointer to instance, but params count was on the plugin factory. So let's change our plugin here such that it retains a pointer to the factory that created it. This will be reasonable, I think. Let's see if we how we are storing this. Right, so we are storing it as a shared pointer. That's perfect. Zack plugin, DLL plugin, plugin instance. Here we have cached samples and stuff. So let's give it then of course we'll need to set this factory when creating its own instance, and factory const reference plugin. Then we add this here, zack factory is equals factory, and then of course wait, this is to be expected. Here we need to add the factory, and this is a bit not ideal because we cannot take a smart pointer on ourselves. We could change it to a not smart pointer, but then if the factory gets removed and the plugin still exists, that would not be good. The other option what we could do, of course, is we could just add a parameter to make, which will need to be then filled in by the calling function, which will provide a copy of factory. That is probably the quickest solution. But that will complicate things. How do we make this elegant? Let's see again where we have. So we create here a new instance of factory, and then we use it. And then if we want to keep it, plus the thing, if it keeps a reference on itself, would end up. Okay, that is complete. So there are a few things to consider. If we would put a pointer on the object itself that would point to itself, then the object reference would never go out of scope, and thus the object would exist forever, so defeating the purpose of creating a smart pointer. What we can do is we could add a weak pointer to the object, and the object would then, whenever used, create a strong pointer from it. So for example, each time it creates a plugin instance. Or we could just, as said, not use a smart pointer but just a normal pointer to point the plugin to its factory. And I think we will do that, since this is really the simplest approach. We would just then, just as mentioned, need to add a safeguard to check whether the thing still exists or not. And there is another thing that Qt offers, which we actually might use here. It's a so-called Q pointer, and this Q pointer is something that behaves a bit like a smart pointer, but it doesn't hold references like strongly. It just becomes nulled if the object goes out of scope. So for our use case, this would be good enough because it allows us some amount of safeguard against things going out of scope, while at the same time it is quite quite simple. So we have here a Q pointer, then here of course we need to change the definition here, and then just this can be directly assigned. So this behaves like a raw pointer for the most part, this Q pointer, but if for whatever reason the factory instance would get out of scope, our Q pointer would become null, and then we can, before we use it, just test whether it is null or not, and this resolves the issue. So here, so let's test it here. If this is null, then return an error, or is null. Thing should be here, pointer. So let's see what functions we have on this pointer thingy. We have is null, so is null should be fine. Punkt is null. Why is that complaining? The plugin factory. Alright, because we did not define it here. We only defined on the plugin, so here we ignore it. But there and then there where we use it, here we just add this. CDLL plugin should be. Should take plugin factory. Of course, is this defined? This is not yet defined. That complicates, of course, also things. Need to say that this will be a class if it's not yet defined. Okay. It's complaining. So there are two things we can do to make this more elegant. So this is a pointer. This should be always happy. I'm not sure if the Dingsbumster, if this pointer will be happy with this sort of forward declaration. Plugin. Let's see what it exactly complains about. Okay, so this, of course, we know that this is not complete. Let's turn this off. Compile. Okay. Doesn't like that type, but this is of type plugin factory. This is const because this thing here is a const function. That's why it's complaining. So we just fix this by saying we want a const pointer, although that will then may be a problem here with the assignment. So we just add const here. Now it should be now it's not happy at all. Wait, what did we break? It's const, this will be fine. But it is not. Compile. Does not like this approach. So let's leave this as it was, and then just here in the plugin just tell it that it should unconst the thing. Zack. Not the most prettiest solution, but good enough. Okay, so this is now fine. Then we go to our incomplete function. Or was it here? And then we check if factory. If this is not, then we return. Then we just return the empty list. And if it is, then from factory we can get param count. So we have resize, and then we just use here the opposite. Then we of course first we need to of course get the list of this thingy. So instance get params, but this wants already a pre-allocated list of simple var type. So we need to create this thing as well. Params count. Okay, and then we pass this to that. And if this returns an error, so int ret is equals this if is plugin let's see is success. We already defined such a check, so is success, or rather if not success red, then we just return parameters like as an empty thing. Although we should clear it before that, or we do it differently. To put this here, and this whole function, this will stay as is, and this we will do only before we actually copy the things over. And then as a return value, we don't give a return value. So we have here the params, and this needs to be the other way around entirely. Maiva to Kuva. Okay, then we return params. We get the values. In case of an error, we back out. That should be reasonably complete. So now only those two functions are missing. And of course, let's see to our test plugin. If we have here everything correctly. So we have here the infos which are set as channel count. Okay, that looks correct. Then get params. Okay, we have not implemented those yet, so this will also need to be implemented. So let's do this now. But we already have a channel count variable, so here we will just for size t e is equal 0, e is less than count for e case null channel count is question for switch e case null channel count is the params at e punkt to or get int get U64 we don't have just get int, we don't have the other, this is what we want, and break. We should of course here we need an I++, and we should maybe define the individual channel parameters somewhere. Plugin param, so just plugin param plugin param channel count is the 0th one, although we could also use an enum, that would be maybe even more elegant, because then we get auto incrementation. Enum plugin channel plugin params plugin params plugin param channel count, or just plugin channel count. This is 0, and then when you add more, they will be auto incremented, so this will be more convenient, and then we can use this here. And then of course the opposite case, param from set value from channel count. Let's just hope not everything just defaults to the boolean value, because this is a problem. If you have different types and it is to automatically pick a conversion, it might end up picking the wrong one. So since pretty much anything we might want to feed to it could be also interpreted as a boolean, we will rename this one to set bool instead of set value. But this of course means we need to change this here as well. This will be a safeguard so that if such a situation happens, it will not run into, for example, if we would have just an integer and it doesn't want to use any of those conversions, it would always default to boolean, which would be, for our use case, absolutely bad. So this will be safeguard against this. So here we had this was get param, then we need set value channel break. Yeah, that is fine. So this here is already implemented. Let's build it quickly. Okay, it doesn't complain too much, just some warnings. So let's continue here. And we already had something that to some extent does these conversions. These are here, these two thingies. So for example, get param default. So let's see. We want to need the type, but the type we know. We have resized it. Okay, so we'll do a few more changes. We'll change this. Will we? No, let's work without. Let's just grab this for now. Let's just grab both of them because we will be converting. This one is more convenient. Okay, so first we want to convert from my variant to Q variant. So this we leave for later. But we just have the types on hand that we want. My variant get type. Okay, and then if it's boolean, then return my var punct to, or was it get bool? And then we just repeat that. So this will be get int64. Oops. Get uint64. Get double. And do string. String is a bit more complicated. Get string data and get string length. So get string length. So get string data and get string length. So q string from char array. Get string data and get string length. We have enough. Yeah. Closing brackets. So this is this, and if we have an unknown type, then we return just Q variant like this, which will be an invalid type. And now here we just need to do some copying around, because now we of course want to start with the different variant types that we might have, and then create the right Q variant types from it. But here we will need to add some more leniency, since there we have much more types, and we don't want to default too often to some invalid ones. So and we'll also add a q assert 0. And this will break in a debug build the execution and tell us that something went wrong at this place. Oops. Type. Okay, so boolean is quite simple. This is like this. My var. My var. This thing should already exist. And then we put this into a default case. My var set bool q var to boolean and no return. We don't have returns here, but breaks. Let's just set value to long. Oops. To long. To double. And set value, and we want to set a string. Right, I think there was one bracket too much. We can do it in a hacky way. To string to. This is a wasteful operation. You could just make it to string and then feed the to string both parameters then directly into the set value for the string, but then it would not be a one-liner. So let's go this a little bit detour like route, and then I said we need here a few more types for this to work. So char and short and int, and do we have just long? I don't think we have just. Oh, we also have just long. Then long as well. And here, do we have uchar? Uchar we have. Okay, uchar, ushort, uint, and ulong, and long, and double. There is also a float. At least Sinus float. Oops. Let's see if they also have this float. Okay, this complicates things. We also have a float. Okay, float, but float 16 is like really low. That is not typical to be used. But yeah, let's just add it as well. So maybe a bit more structure to the whole thing. Yeah, like this. Okay. That should cover most of the imminent cases, and if we forget something, then we'll just here be broken out in this QAssert once it asserts that something went not as planned. So we have the conversion in both directions, so let's try it out. I think there is wait. Okay. Why is this not happy? Meta type returns Q meta type. That should be happy. Let's see. Meta type. Why did they have to change it? It was so nice when it was still simple. This is a whole class. This meta type thing is an entire class. parameter is this type. Let's see what returns this. Right type. That is annoying. We have some other options what you can get. We have meta type, we have type, but this is two variant type and they don't want us to use type ID as something else. What would be type ID? Meta type ID. Okay, maybe that's the right thing. We will need to check it out. We still have somewhere a problem. Does not like our Q pointer usage apparently. No, that's just a warning. So they have changed Q pointer to internally be just a pointer. But this is a Q object, isn't it? It should be fine. Plugin factory. This is not a Q object. That is not great. And our plugin factory. But the plugin factory as such is not something that we would load from a DLL, so we really just can make this to be a Q object. So now it should be happy, unless we break something else. Almost. Oh, that needs to be public. Q object. Okay. Okay. This is not correct. This should say channel 1. So we have here a bug in our window implementation. Let's see. Do we get the name from? So get params. Here we created get param name I. So this looks correct, but for some reason it plugin. Oh yeah, plugin name. That is not correct. Param infos. Index. Param name. Okay, now it should be correct. You would add channel count. Let's say we want 2, but it only created 1 channel. So either we ignore this parameter or we have some other issue. And since we don't have the ability to open it, since this was a homework assignment, we cannot check whether that was correct. So we will just put a breakpoint somewhere here, the set parameter, and then see if channel count is 2 after we added it. So 2. Okay, channel count. Channel count is 1. That is not correct. Let's see where the mistake started. That was a bit too much. Okay, let's just re-edit it without starting anything new. So we have params. Params is empty. Params is empty. That is not great. This means our window is a bit more broken. Get params does not return what it should. So I put a breakpoint here, restart it again, add wanted 2 demo. Okay, this is called. That is so good. So far so good. We have the plugin. We have plugin param count. We get now the type view long. This is correct. This is not correct. It should be if this exists and not if it's not exists. Yes. Add to run. We don't. Yeah, and we have 2 channels. Let's run it now. Start. Okay, it added the 2 channels, but it still only is plotting one of them. Or both always show the same value. That could also be because it detected 2 channels correctly. So it's likely that it would plot them also as it should. So let's debug what's going on here. So we go to our get samples, channel 0, channel 1. Yeah, so the samples are always the same. Yeah, we have not implemented yet the support for Modern 1 channel, the actual plugin. So let's quickly fix this as well. So we have our demo plugin, we have vector of doubles, and what we will basically need will be a vector of doubles, or we introduce a structure for each channel. I guess this is the more elegant solution, so let's go with it. Stoked as channel data samples time samples, and then here make vector of s channels, call it channels, and the semicolon here is missing. Zack. Okay, with the log we have here as well. Demo plugin. So here we have our run. We will only take the value when run is engaged. We will not, in other circumstances, care for what it is. What we need now? From there. Okay, so let's put this here. Put this there. Channels punct size channel count. We should log for this. Log unlog, or we could do it like the modern way. Just put it in the scope, which looks a bit weird since you have such an open bracket, but it's the recommended way because it's really foolproof, so you cannot forget to unlock it. And also, if we would use a name outside of the scope, outside of this scope, and then the same name here inside, if you set your compiler to a sufficiently new version of C++ and sufficiently high warning levels, etc., that would also not like compiling. In this scenario, it would complain that the name is reused, even though old C++ didn't care. So the old C++, if you had different scopes, it was keeping them apart, and in principle this was a workable approach. But of course the downside here was that if you forget something and then keep the name somewhere else, then it's still there, and then the behavior might not be what you actually wanted it to be. So here for in size 10 e is small 10, e is null, e is less than a channel's size. Channel size e plus plus this one, and then channels von e punct yeah, this is here, and here we just want to check that channels is less than channel count. And if it is less than channel count, then we just channel at channel into the log, channel at channel, data samples, time samples, data samples, time samples, zack on zack. Okay, let's run it. Add to run, and we have 2 channels, and now we could in principle add as many channels as we wanted. It would nicely plot them. Okay, so let's stop it. So any questions so far? Okay. If there are no questions, then let's continue. So this works. Let's quickly close on the windows and see what else you would want to add. So the next thing in our UI, which is still kind of missing, is here this log. Generally, when doing things which are targeted at a more sophisticated audience, like programs to control your lab equipment, for example, it is always a good idea to have some sort of event log, something that you could write events to, so that if something goes wrong, the users can review what might be the problem. So for example, here when we press start, we had seen that it would go through all the plugins and try to start each of them, but it only returns one return value. If something failed, then what kind of failure it was. It wouldn't even tell us which plugin, for example, failed. So this would not be great, because you would just see, okay, start failed, and you have 10 different plugins. Now find out which one is buggy. That's kind of annoying. So to work with such scenarios, what we do is we simply here will be using a log in which then we just write the name of the plugin which just failed before we return from the start function. So this log is kind of very incomplete. So let's first open the not this one. Forms from don't have any forms. Oh, we don't have forms, so this was done manually. Okay. To do. Okay, so we have here the log, and we can add multiple tabs. So we could even have like a normal log and a verbose log. But I think for now, just to keep it simple, just go with one log, and if someone wants more logs, they can add them later on. So we will need some document for the log. Plain text edit log asterisk. Okay. We have a new log which will enter here instead of the label. We will do a few things, so we'll set it read only. Set read only true, because we don't want to write the log like through the UI, but the log should only be written by the application, and then we'll need to define an interface. So the simplest approach here would be to just add a slot on our data panel that would be triggered whenever there is a log message, and then it would write this message to the log. So let's go here with our slots. Void on log line const string reference line, and we might want to some flags. Int32 flags is equal to 0 by default. qwin32. Yeah, that's all we need for now. And let's just add it to the very end of our file. Data panel on logline. Flags we can use later for something, but for now we just want to have the final line, so q string text line, let's call it mp log, how did I call that, just log, that is a bit too log, let's call it log text, that would be a bit more less confusing. Log text, okay, log text, append plain text, and plus a new line, and this thingy will be of course later on line, but we also want the date, so let's say this is plus equals the actual line that we want to have finally, but initially this equals q date time current date time to string. We can format it let's say one just hours and minutes and seconds. Although the M might also be for months, but I think M for months is capital. And there is like a specification which letters correspond to which part of the calendar. Actually, we could just quickly look this up so that we can do it correctly. So just search for Q date time. Format string. Okay, so capital M are days. MS. Okay, this is what we want. We could also add CZZ for for milliseconds. That will do as well, and we will not care for the date. We just want the hours and seconds and milliseconds and the line, and then we of course need some spacer maybe. So double point space. This can be a terrain. This block text can also show HTML formatted text with, well, at least a very simple version of it. So you can set colors, make things bold, etc., etc. It's not a full web view, of course, but later we could use the flags variable, flags argument, which we have here, which is not doing anything yet. We could later use this for example, making certain lines which correspond to an arrow red, while lines which are just debug messages remain black, and maybe add some like green for success or other colors to indicate other types of events, so warnings in yellow, etc., etc. But for now, this is just all we want and all we need, and we will want to connect this to our plugin manager, and later maybe also to other things. We have our plugin manager, connect plugin manager, comma. Well, we don't have a log message signal, so let's add it. Plugin manager signals. Fetch signals. I don't have a just log line. This is good enough. Okay, log line reference, comma with this, comma. On the log line of reference. Okay, so it is already connected, and then we go to our plugin manager CPP, and then go to the start slot, and if something is wrong, then we will bracket. Then we will emit log line. Oops. Or plugin %1 failed to start, comma error code %. 2 .arg. The first one is the plugin name, plugin get name, but it won't get label. When you have get name, then get name shall it be, and here we will just use our status value. Okay, so now we need something to, of course, trigger such an error. Have an plugin demo plugin. Do we have a start here? Yeah, no, we have a restart. We should have start somewhere here. Alright, we start the thread, so let's break it somehow. For example, if channel count is greater than 16, then we need a new code. In principle, such an error we should already throw. Such an error we should already throw when the user attempts to set this value. But here, let's just throw it here, and then we, of course, will just set it to 16. So add, let's say 17. We have our 17 chance, and then we start. Oh, we ran into an error already. Plugin vector. That is not great. Demo plugin S channels. S channels. So we need to change one of our test conditions here. Instead of count, we will go just really with size of this. This will be safer. 17. Okay. Start. And here we get the error message -5. We'll try to start, and of course stop doesn't do anything because it stopped. Also, I see we might have added one unnecessary new line. Apparently append text already adds a line break to the end of the code text block, so let's remove that. Let's then again add 17. Yeah, and as you see, of course, the date and time here is also displayed correctly. Well, just the time in this case. So of course, when you put the cursor somewhere in the middle, then it will no longer be auto-scrolling, but we could add some improvements to make this always auto-scroll, or add an option to disable auto-scrolling, etc. But these are minor improvements, no reason to invest too much time in this right now. Okay, so we have our demo plugin. Let's repair it, or actually we could leave it as is, since with a smaller count of things it would be fine. One could, of course, make the whole mechanism more elaborate. We could add status columns for the plugin, so that for each plugin the message will be cached and displayed and things like that. But I think this is not really for us here necessary. What we would be more interested in would be some mechanism how a plugin could also generate a logline, because if the plugin runs, for example, a thread that generates the random data and it decides to throw an error for whatever reason. So, for example, if it would be like something that reads from a serial port and it expects a certain data format, and then the data that it receives are somehow corrupted, then it would either abort or reset or something. But we would of course not want this to be a silent event. We would want to either abort the operation, although that usually will end up more annoying than useful. So what we would want is something that will throw an error, which we see, and then the operator has the choice to abort the rest of the measurement or not. Because in some cases you might, for example, want to just monitor pressure on the side, but it's not essential for your experiment. It's just a nice to know information. If you have something that is you done in a vacuum chamber, then usually you would want to have a good pressure, but you would not really require this information to be recorded all the time. You would just add it to your program so that you have one more information you can watch, but you wouldn't want then the whole measurement to be aborted only because the pressure gauge failed, for example, or even worse, just because of some random communication error. So in such cases it would be nice to be able to just log those things to the log that we already have, but not return an error somewhere that would cause the mechanism to abort. So we will add this. Let's go to our plugin and let's think about how we can do it best. So our plugin interface was defined here, and here plugin abstract plugin, yeah. And one thing we see instantly when handling this is that we can call things on the plugin, but the plugin does not have direct means of calling back. So we could of course kind of cache the log lines and then just have a function which will be called periodically get log lines, but this is not a very user-friendly approach. What we have implemented further down somewhere was this API this one, that allows us to pass a malloc and a free function to the plugin, which the plugin then can use to do something with it. And what we can do is we could use this structure to give it also a log function. So it would call this function whenever it wants to log something, and this would be a function on our own process which would then do something based on that. So let's do that. This is a reasonable approach. So this plugin API is a good place to put such callbacks in. Since the callback in nature will be a bit more global, it's actually fine to have it here. We can quickly check one more thing. Where are we using it? Plugin 8. So here we have our API, and here we pass it to the plugin. So what we notice here also for now is that currently this table, this function table which we are passing there, is global. So all the plugins will receive the exact same table, and just if we want to log something, this would be good enough because we just need the log function. But we would also want to know which plugin issued this log entry. So we would need to think about a mechanism how we can communicate this information. Because if we look again into our plugins, plugin, the name thingy is something that our application keeps, but it's not actually a attribute on our actual plugin interface. So the plugins are unaware of their own individual names. They can, of course, is this plugin? Yeah. The plugins are not aware of their individual names, and the DLL as such, while it is aware of, like, for example, serial port plugin, it would not be aware that we have called serial port for pressure gauge and serial port for linear stage and serial port for BNC works and serial port for whatever else hardware we might want for Arduino or something, or whatever else other hardware we would want to control. So we need to find a mechanism that will allow us in some elegant way to resolve this name. And there are in principle two approaches we can go. One would be that the plugin, when it calls the log function, the instance of the plugin would have to return a pointer to itself, or not return, it would have to give the pointer to itself as an argument. That's a more correct way of saying it. And then the log function would then go through the list of all the plugins, check to which pointer this pointer matches, and then return, and then use this name appended or somehow integrated into the log line, such that when it's then printed, it will have the information which plugin issued this log message. This is a workable solution. It's a bit convoluted, so we could also try to think of other solutions to this issue. For example, the table with the functions that we are passing could not be one that is global for and the same for all the plugin instances, but instead we could generate a new table for each individual plugin, so that every plugin would have an own dispatch API dispatch table. And while creating like functions for every plugin would be doable with some creative code generation, the actual approach you would take there would be to just have this table not only containing functions but also have it containing additional parameters. So we would give an parameter to the plugin which for it is opaque, which in our case would be a pointer to our own plugin holder object, which contains the name and stuff. And the plugin would just always have to give this pointer, and would just assume that the pointer so from the viewpoint of the plugin it would be just a void pointer, but then we would always assume that the plugin is correct and the pointer is correct, and we can just cast it to our own DLL plugin object type and then resolve the name from it. So that would be the second approach how such things would be typically implemented. It is it is more straightforward and has the advantages that we could then really make more customizations on a per plugin basis. But on the other side, it uses more memory, because then we need to allocate, of course, such a table for every individual plugin, and then we of course need to track that and free it once it's done. So I think for our use case we will just go with resolving the plugin instance. When we use a map or a hash table, then this resolution is quite fast, and we also don't expect log lines to be generated with, well, hundreds and hundreds of them, rather a few lines here, a few lines there. Then the computational complexity to print such a line to screen is not of our concern. So let's go with this. So let's go to our table and define the new function. So this will be plog line. This thing would contain a void pointer which would be per instance. It will be the plugin itself. Then a const char then per Leinster and unsigned int, that's our uint32, uflags, in case we add some flags in the future. Okay. Log line. So what was it? Plugin somewhere here, da. And plugin, right, I could of course also quickly from there grab the definition, because this we will be using again. Plugin, do we find the function somewhere? No, we only have them here. Void my log line. Okay, I press down think should be fine. And of course this we will need to add here. Let's put a breakpoint here and then just add some simple log line for testing demo plugin. For example, when we start and then the thread runs, then we would make here m, or was it g? No, m API logline this comma line string comma null. It would be for example we just something like this. Okay, so we have a breakpoint there, so once we run we should enter here, add one start, and voila. So this works as expected. So now we will need, of course, to make this work. So we go to, this is a bit complicated because we need to get a pointer on the plugin manager, on which currently only the UI holds a pointer. But we should have the GUI thingy, so we can use it once we include it. Was it just here? Data panel. The GUI plugin manager. I think then as on the plugin manager we could have a function log line which will then do the resolution and then call the other slot. So let's do this. Zack. Plugin manager. Oops. Zack. Public functions void my logline. String plugin name. Use plugin name. We have here plugins. And if plugin.data is equals instance, then break, and plugin name is equals the plugin name. Get name. Okay, and if this is empty, so if for whatever reason we didn't find it, then is equals translate unknown plugin. Okay, and now on emit log line, the message would be what would it be? Plugin name. Yeah, probably we start with plugin name and message send that to string for array line comma flag in case we will have some, and depending on the flag we could also here have a different string, like one flag says message, the other flag says error, the other flag says warning, etc. But for now let's just go with message. So let's run it. Add demo plugin one string start. Don't need a breakpoint anymore. And when stop, start, stop, start. We should also add a stop. And I see also we are missing a reset button to reset the plot, so we might want to add this later on as well. Data panel, demo plugin, run, stop, and here plugin stopped. Actually, we don't need to add demo plugin because we already have the name, so we just worker started, stopped, and here started. That brings us to a potential problem. Brings us to a significant problem because this runs in a different thread, so that will cause issues. We need to properly fix this. Even though we cannot seemingly trigger the issue right now, if we would have more plugins starting more threads, we would run a situation where this log line will be called multiple times and from different threads, so we need to somehow synchronize this. And this emit should be safe, but accessing the plugins here is not. So for the plugins we'll just add a mutex. Plugin tags, plugin list. I changed this to list, so that actually we could also have a queue read write log. This is a bit more nicer. I changed the variable name here so that we get an error whenever it's accessed, because we need to add queue log reference. And let's call this not wait, read write log. This could be made recursive. Plugin mutex. And this is const, so okay, and let's call it plugin log, not mutex. Okay. Plugin manager, let's just see whether we now get an error because of the plugins. Then we need to change it to list and add a, so add plugin will be a write logs. Oops. Q write log, plugin list. Here start is a read operation. We're not changing the thingies. Stop the same. I think we only had one write operation, and my list is also a read operation, but we want this to be scoped. We don't want to keep the log, although we don't really care. We could release the log. We could keep the log. It will not break anything, because this emit here should be a queued event, since it's not from the same thread on which the listener, the receiver exists. But just to be on the safe side, let's release the log before we invoke this. Okay. So this is now working correctly. Okay. Good. So of course we could now add more plugins that do the two different things. More plugin DLLs. I think we had some homeworks. Parameters. Yeah, so here we had these plugins, but this was still for the for the old plugins, but they were just part of the main application. So let's make this to make a new homework here. 27112025. Wait, or was this already 11? How many lectures ago was this? 2 lectures ago. I do not remember. Can you tell me, did you implement this as DLLs or just as the as individual plugins inside the main application? Mm-hmm. So it's not an own project like the demo plugin here. Own project, okay. Okay, then we don't need to make this a homework, since apparently that's how people already done this. Can we think of some other plugin that would be easy to do? We had this other tool with the different network thingies. Networking here. We had this apparently is still open somewhere. Yeah, it was still open. Okay. Here. Right, where we started different types of sockets and then communicated between them and the main application. So what you could do here as homework then would be to create a plugin which can connect to one of these servers, or with a server like this, and then just receive some data from it to be plotted, for example. Or to make it simpler, since we already did plotting, something that just connects, sends some preset string, and whatever it receives, it then writes inside of the log. And this thing just echoes. So here you would just run TCP server Qt, which starts an instance of itself that runs as this server, and then what you just need is to make a plugin that would connect to the server, send to it some preset string, and then print into the log whatever it receives back inside. And this could be done inside the start function or inside a worker thread. I think this would be then not too complicated. So let's start over. So homework from the today. It's from parameters. 1 IP, 2 port, 3 connect message. The plugin should example Okay, and yeah. It sounds like it should be easy enough. So it combines the two examples a bit together. It is not, I think, too complicated to realize. You basically just create a plugin, how to start and stop threads you already seen in the demo plugin as well, and then just use a network connection to send some data and then receive something back that is printed into the log. Any questions? No questions? Okay. So let's see what we do next. So we can already create plugins. We can make them print things in our log. We can make them show graphs. So this is already all quite nice. But of course, if you want and to create an experiment, what you would also want is to be able to specify some operations in some sequence or read data and then based on them make some decisions and write some other data back. So basically what one would want is some sort of ability to script the behavior of one's own application. And Qt has for this a class which is quite useful, QJS engine, which is in principle just a JavaScript engine that can be interfaced with reasonably easy. You can even create own objects with functions which then will be called on the different Qt objects connected with it, so that you can expose whole objects to your JavaScript. It is a bit tedious to create all the necessary bindings, but once created, it gives you a great control over whatever aspects of your application you want to control through this means. So this of course is a bit more of a larger topic, let's say. So today we will just prepare the UI for that, and in the next lecture we will be looking from the start of the lecture into implementing this JavaScript engine. In principle there are many JavaScript engines to pick from, so the one offered by Qt is just a convenient choice since it's already optimized for the use with Qt and bindings the way Qt likes it. In principle, you could also use Google's V8 engine, but this is significantly more labor intensive. And usually the main advantage would really be if you would want to run some heavy calculations inside JavaScript. Then the V8 engine would be superior, but if you just want some light scripting, then doing this in Qt's JS engine is simple enough. Other options would be, for example, JS Quick, which is an extremely lightweight JavaScript engine. So it really depends on your use case which one is best for you. But since here we have a Qt project and we just want some light scripting, we will be just sticking to Qt's own engine. You might have heard of other scripting languages like Lua script, very popular in game development. So, or Squirrel script, which I don't know where it's popular, but I ran across it at some point. It's somewhat more C++-like from its syntax than Lua. Lua is very well, Lua is Lua. It's not similar to anything that much, but generally, of course, you could choose also other scripting engines. The good thing about the one from Qt is that you also can debug it with reasonable ease. There are some third-party packages that implement a quite nice debugger. The much older version of the script engine that Qt offered had, in fact, also from Qt debugger, which was provided, but unfortunately, when they modernized a lot of their things with Qt5, they dropped that in favor of just using this new JS engine, which in principle is better, but lost some nice functionality. In principle, what of course one also can do is to add some interface to, for example, Python. So just create own Python bindings and then write scripts using that. But this is then everything but lightweight. So for normal simple scripting, an own simple engine is the way to go, instead of creating an infinite amount of dependencies if you would want to add full Python support to your application. What also one can do is one can interface with other software packages. So for example, what you could do is you could create some interface DLL for your application that could be used by some third-party script, or by a third-party application that would run its own script, and then it would be even more flexible. But I think for our use case this would also be overkill, so we will here be only really looking into using the standard scripting engines and just scripting inside our own application with no more complex interfacing with other things. So for this we will need to first of all think about where we put our script data. I think either we replace the whole panel and just have a tab like plugins and scope and script, or what we also could do is we could just replace the scope itself with a scripting window. That might be more convenient in case at some point we would want to display more informations with the plugins, like error messages, cache them and keep them displayed, for example, or some status, some other status or memory usage. Then we might want not to look on the scope, but then still look on the plugins when changing things to our script, or that we know which names our plugins have instead of switching forth and back. We would also just see them instantly in this place. So we'll add another tab control, data panel. We already have here one tab widget for the log, but we only use one tab, so that's kind of boring. Center widget, plot here. That will be, we just call it tabs, and then we will add a widget. So one is the plot, and the other one will be Q widget asterisk path script widget, and we need a layout for that. Let's go with a grid layout, Q grid layout, script layout. Okay. Wait, we also need this, and then let's see what this is created. This is created here, and here we set it center layout add widget. So center layout, the things will change. This is equals new tab widget. That will be set into our center layout. Tab widget, tabs and widget, add tab, tab named scope or plots, and then the other one, this, new widget, new layout, scripting. Okay, this just adds an empty tab, but you can already see how it will look if we like it. Oh, that's looks reasonable, I would say. And here we will then want to add some text edit, but generally it would be better when the thing would be a bit bigger. But I think we don't have any means of saving the geometry of this thing, so we should add this maybe as well. But that we might add later. So first of all, we will so there are now two strategies how we could add this scripting control widget. One is, as we started, we just add it to the current panel and add more and more members. If we would be creating a more complex project, we could now create an own file, an own class, called it like C script view, for example, and then integrate everything just in this script view, and then integrate this script view into our data panel. But I think for our use case, the script thing will not be that complicated. So we will have something to load the script, to save a script, text edit, and then probably something to maybe start a debugger if we later on would add a proper debugger to it. So I don't think we will need a lot of additional components, so we'll keep it here. And if we decide that we want later to move it somewhere else, that would not be that difficult. So here we'll also use a plain text edit, mp script text, and what else would we want? So we would want some buttons, so let's add a small toolbar. mp script and what actions would we want on our toolbar here? Well, load script and save script, or maybe we should call it open script and save script. Or load script and store script, that are all good names. We might want to add later things like text search or something, but this would be for later. Now let's just focus on the main thingy. So scripting will okay, so let's first create our sub toolbar. In principle, we don't even need to save the two things, we can connect them directly. So let's actually get rid of those and just add 2 slots instantly. Like on start stop, on load script, on store script. And action or open comma this comma slot on the load script. Oops. Save as, so that it's clear that it will not remember the last file name, but we always need to tell it where to save. To our script. So this goes to our layout widget. And then of course the next thing will be here, the text edit. New. This time of course we don't make it read-only, we add it here. Okay, let's see, we will need of course those two functions to be implemented, otherwise the thing will not work. Zack. Okay, let's run to see if we like how it looks. Well, generally this style here seems to have a little bit too little contrast. They, I think, changed to use the a more Windows 11 like style in one of the later Qt6 versions. So you could also want to change the style of the whole application. Maybe we should do it so that it looks nicer. Somewhere in the constructor here. Let me think for a second how to do that. Q application. Oops, too many typos. Q application. Set style. Q still factory. Create Fusion. That is a reasonably nicer style. So as you see, much more contrast. And yeah, I think this is nicer than the one, the new one. I think we could also have like an old school style. What was the name? I guess Windows Vista or just Windows. Can try. Oops, that is now the wrong case. Yeah, okay, this is very old school. Is there also in Windows Vista one? No, I think this failed. We just defaulted back to the. I don't think there is an XP style either. I think there we just default to not having a style set. Just using the default style. So let's go with Fusion. That is like I think a good compromise between modern and still having reasonable amount of contrast. So the nowadays used approaches for UI design are made to look nice if you don't have to work with it and have almost no contrast, which is kind of garbage. Set content margins. So I really don't appreciate the modern UI designs that are nowadays becoming more and more common. So let's here stick with something a bit older. And I think we also had an example project here somewhere where we what was it, Qt GUI test, I think, where we had a text edit. So we can just copy things from here. Well, actually we only have one thing to copy, so the other one we will do manually. We can close this again. Plug in them on the data panel. So load script. Load script and Qt test. That will be fail to open file %s. And of course here we have our mpscript text set plain text, and well, we will be also now implementing the saving. So I think of course any submissions for this homework will no longer be possible after this lecture, but I think that was one of the very first things we did, so you had more than enough time to implement it by now. Save file name, slot storage. Read write. Failed to open file, that is an error message, and then file write plain text to plain text punct to UTF-8. That's from, don't we have a 2? Now we have 2 UTF-8, okay. This is from UTF-8, so this is fine. Let's make this a bit more nicer. And let's try it out. Scripting open something that we don't want to break. Yeah. Save as Pause, panel, data panel, zack, not here, data panel, yeah, so loading and saving of the scripts already works. What else can we improve? Generally this side here still doesn't look very nice, so we could, for example, move this add and remove to the top. That will probably make it a bit more elegant. So we have here our plugin menu, no, plugin bar, and we inserted it here, but we will want this to be the first thing before the tree, so let's do that here. Let's run it again. Since we are using here this row plus plus, then it should automatically increment and ensure that it is where it should be. Yeah. This looks better. Of course, we could use some images if we would have them here for this purpose. So, but I think what would be more important would be something to allow us to save a certain geometry of this whole thing, and then have this geometry maintained instead of having to reset it each time. So we will add now something to save settings. And there is a class called QSettings, which as the name suggests is quite suitable for this application, but it needs to be configured the right way. So the way it works, depending on what parameters you give it, you can either use it to save your configurations to an ini file, or you can also use it to save your configurations to a to the Windows registry. So the latter option is of course kind of out of date, so we don't want that. Extern Q settings, the conf, let's call it. Oops, small o as a pointer. So this again we define here somewhere as rptr at the beginning, and then we will initialize it. So here is equals new Q settings. Okay, and what do we need? First we need to give it the path. So Q application, we will just to save, we just want to save it in the application path. So application dir path. Of course, if this would be an installable and not a portable application, then we would do it slightly differently. We would get some user's profile path and then save the information there. But for our application here, we don't want to spread the files across the file system. We just want everything to be reasonably close together. Data panel punkt ini. Oops. And then we of course need to specify the right format. So Q settings index ini format. Yeah. And of course, once we are closing everything, then we sync this back and delete it and set it null. Okay. So we have here our thingy, and then let's start with the window itself. Somewhere here. Stock geometry. Value. Then we can create specify a string as a key, and in case of ini files it will be first section, so let's call it GUI, and then main when the yeah, main window basically. And at default value we don't need, and this is a 2-byte array. And of course we need to save the same informations. So set value, comma, this save geometry. Okay, let's try it out. So of course the first time it will just open as it was before. If we now, let's say, we make it bigger and move it and make it even more bigger and then close it and then start it, then it will have maintained its size. So the next thing we will want is splitters to keep split, because if we now just have the window, we just have its position and its size. We don't have any information saved about the internal mechanisms. So let's see how many splitters we have. We have a horizontal splitter and a vertical splitter. Okay, so let's save and restore them as well. So restore geometry. This was the main when the H split, and the other one will be V split. And here I just copy this a few times. H split, V split, H split, V split. Let's run. Okay, now we will move them somewhere so that we like it. We can close it, we can start it, and HV, HV. That failed. Is it not called geometry? That should be called geometry. With splitter you need state, not geometry. Restore state. Save state. Okay. And voila. And then of course we could also save which tab was open and add such other complications. What we also could do is we could add here a mechanism to save and restore the lists of plugins, but since we are today have a little bit less time available, we will not do that now. So this might be something for one of the later lectures or as a homework at some point, to add the mechanism to load not just scripts but also somehow a list of plugins which will be added here. Although what we also could do is we could pretty much move this mechanism of loading plugins into the script, so that when we run the script it would first populate and configure the plugins here. So that is something we can yet still decide on. You should have received an email about the evaluation of the lecture. So I think this will start like in 5 minutes from now, that you can start filling out this things from pool, this inquiry. So I think with the lecture part we will stop for today. I will stop the recording and upload everything to Moodle later.